Okay, now we talk about sampling distribution. So we talk about sampling. Yeah, this is all about the sampling and how it distributes. So remember, this is about sampling. And so far, sampling has two types. First is a sampling distribution of the mean. Okay, sampling distribution of the mean, which is the probability distribution of the sample means with all samples having the same sample size n. So this is the sampling distribution of the mean, and another one is the sampling distribution of the proportion. Okay, which means that it is the probability distribution of sample proportions with all samples having the samples size n. So again, this is all about samples. Okay, this is we talk about sampling. It's not okay. So this is the distribution of the sample. Okay, I hope you guys can understand why. Later on, you guys will understand why I stress out with this term sample. Okay, let's talk about sampling distribution of the mean. Okay, I'll give you some example. We work out with examples, so I hope you guys we can follow and you can understand it better. Okay, suppose we have students that have many WhatsApp groups. So everybody, so one people probably have 10, 20, 30 WhatsApp group for themselves, let's say. So, and then let's say we know that the true mean. Let's say that we know that the WhatsApp group, the mean of students to have WhatsApp group is 30, and then the standard deviation of this is around 10. The standard deviation uh, of this mean is 10. Okay, so later on let's say and then I try to sample 100 students. Let's say I want to sample 100 students, and then try to ask them how many WhatsApp group each of these 100 students have. So then from there I get also probably one have 50 groups, another one have 30, another one have 20, so on, so forth and so forth. Okay, then I calculate, and then I try to calculate, get all this, and then get the average of this, and then I get the mean. Okay, took the sample. This is the sample mean. So do you think that this mean, the sample mean, will follow the mean? Will you get the sample mean is equals to 30? Definitely no. This is a big no. Probably when you sample, you sample the anti uh, SOCMED people. You know, they do not have any social media, not play with social media. So probably they get lower average, and probably, and then you sample people who are group of makcik bawang. So for instance, so probably they have more than the average, probably is around 50 to 100 WhatsApp groups. You don't know. So then how you want to say that the sample means, the population means here is about 30, but when you do the sampling, so probably you get the x bar here is 10, probably x bar here is around 100. So what is the sample distribution mean? So this is what we call the what we try to say that on in this sample distribution of the mean. So this is what we will talk about. So from that example, then we know that we get the sample mean. So this is not equals to population mean. But then how we want to conclude that the sample mean here is closely related to the mean? Okay, so remember, this is the sample mean that you make the sampling to probably one group of people. One group of people. Let's say you increase the sample size. What we sorry, not sample size, sampling size. So which means that this is for x bar 1. So let's say you include the x bar 2 plus x bar 3 and so on and so forth. So how about the distribution of this sampling mean? So what you will get is, let's say you make a graph and then to try to do the frequency distribution of the sampling mean. So this is the number. You know that this is the number of population mean is 30. So 30, the average is here. So you do the sampling and then you find. So this is 30. Let's say this 20. This is 10, 40, and 50. So and then you do the try to you make the sampling. So first sampling you get around 22. So here, and then another sampling you get 22 here again. So you have. So this is the number of frequency of the sampling number. So you get this. So another one you probably get here, and then you start to pile up, and then probably, and then eventually you will see when you do a lot of sampling, okay, you will find out that the most of the samples, okay, you find out that most of the samples, the number of average WhatsApp group per class is about 30. So this is, and then this will be piled into the true mean. Okay, we'll pile on it this true mean. It's about 30. So how you look at this distribution? It looks normalish. So this is what when you do, and you know that what's the population mean, and then when you get and then you want to test if the population mean is true or not, and then try to do all the samplings, and you get all the information, and then when you do the distribution, frequency distribution, and you will get this pile. Okay, you will get this pile, and then you find that most of the sample mean will pile near or close to 30, close to the true mean. Therefore, for this reason, okay, and therefore for this reason, the statistician concluded that the mean of sample mean, okay, will equal to the population mean. So that you need to follow me here. So the mean of the sample mean will be equal to the population mean. Okay, and how about the standard deviation of here? How about the standard deviation of the sample mean? Okay, the deviation of the sample mean will be equal to the standard deviation of the population mean divided by square root of n. Okay, in this case, square root of n is 100 because we do the 100 sampling. So which means that the standard deviation, so for this case we know that the mean is 30 and then the standard deviation is 10. Okay, so here it will be 10 divided by 100, so this will be equals to 1. So how you will apply this? Let me clear the board a little bit. Okay, so we know that we already know that now we know that the sample mean, the mean of the sample mean is equals to mean, which is in this case is 30, and then the standard deviation of sample mean is equals to sample mean divided by, and this is equals to 1. So therefore, how is applied? So let's say you have this distribution, same distribution like this, you get this 30. So which means that the deviation will be, one standard deviation is 29 and then 31. So the standard deviation to get one standard deviation, which means that this area, the one standard deviation. So which means that here is a 68%. of the population of the sample mean will uh, sorry, how I forget the term, sorry, will fall, okay, will fall under this 29 to 31. This is one standard deviation. Okay, so if you have two standard deviation, standard deviation, which means that two, we see this is 2 times 1, is which is equals 2, so this is will be 28, and this will be 32. So 2 standard deviation, what is the probability of 2 standard deviation? Yes, 95% of it will be, and the sample mean will fall under 2 standard deviation, so 95% over here. So and then 3 standard deviation, so 3 standard deviation is for 99%, okay, will fall under 3 standard deviation, 27 into 33. So this is what how try to look at all these sampling distribution for the mean. So again, we will look at here, so which means that if it's one standard deviation, 68% will fall under this, so 29, so 29 and 31, so and so on and so forth. So this is only 68%. I hope you until now you guys can understand what is the sampling distribution of the means. Okay, now let's move on and talk about sampling distribution of the proportion. Remember that the sampling distribution of the mean, we talk about sampling sample means. Okay, now we talk about sampling distribution of the proportion. Same way I want to how to explain about the sampling distribution of the proportions. I'll just give you an example. Okay, suppose that we know that 20% of people are fans of Manchester United. Say, so sorry Manchester City, sorry Arsenal, sorry Liverpool fans. 20% of the population in the world, hypothetically, know are the fans of Manchester United. Your Man U, glory. Okay, suppose that we know that 20% of the population, okay, of the people know about Manchester United. So actually, and then the parameter here is the actual proportion, is the actual population. So this is, so which means that what we will get here is P, probability for the whole population is 0.20. So this is the probability. Okay, so again, if we take sample of 100 people, same like just now, we take sample of 100 people, will you get all 20 will you get 20 people, okay, are Manchester United fans? Definitely, again, the answer is no. Okay, so this is how we want to this is where we want to look at how the sampling distribution of the proportion, and look at how it relates to the actual population probability. Okay, yeah, let's say when you do the sampling, probably for first group, you go to Malaysia, probably you get 50% Manchester United fans. And then when you go to the England, you do again 100 people, but you go to London, probably you get Arsenal fans a lot over there. Then probably you get only 5% of the Manchester United fans over there. So sampling distribution will be very along the sampling, but we know that the total of the whole of the population, 20% are the fans of Manchester United. So this is what we want to see in the sampling distribution of the proportion. So same thing like the population, sample population for mean. So again, so we know that the probability of the population is 0.2. Okay, so now if we So this is what we call, so therefore the sample proportion, and then you get this one is sample proportion. Okay, if the sample mean is x bar, sample mean is bar, so sample proportion is p hat. So this is the first sample proportion of p hat. So again, this is sampling for one sample. Okay, so how you want to relate this with the sampling distribution? Again, when you do, you know that the probability of people know about is a 20% over here, so put it 20 over there. Okay, so and then you go, and then you can got 15, 25, 30 and 10 over here, let's say. And then when you do again same thing, like you go, you do the sampling, and then you got the probability, and then sampling, you got the probability, and then you start to pile up the sample proportion here. Okay, you pile up the sample proportion here. Okay, again, what you will get, oh, I use Manchester City color here. Okay, sorry. So what you will get is sampling, same thing, it will follow the anomaly distribution. So when you looked at the histogram, the p hat, okay, this histogram of all the p hat, yeah, come back with the Manchester United color here. So, and then the sampling distribution is follow the anomaly. This is a kind of like the basic of the statistics here. So notice of all pile of p hat is around the true p here, the 20%. So which means that same like before, the mean of the sample proportion, okay, is equal to the population probability, which means that this is the 0.2. Okay, so the mean of the p hat is a true p. So the mean of p hat of the true p. Why is the difference? The only difference, same like the sample proportion for mean, is the standard deviation of the p hat is equals to pq square root of pq divided by n. Okay, okay, so we know that p, what is p? P is a true p here is 0.2 times 0.8 divided by 100, and we will get 0.04. So what does this mean? What does this mean again? So which means that 0.04, so this is because it's 0.02, and then we try to draw again. So let me clear a little bit this. Okay, so we know that the proportion, the mean is 20. Okay, no, the proportion, the true p is 20. So the one standard deviation is 4%. So 24 here, and then 16 over here. So this, the area in between here will be 68%. Okay, 68%. So here is 68%, which means that there's 68% probability that for the probability will fall under 16% to 24%. This is for one standard deviation of p hat. So this is one standard deviation. How about two standard deviation of p hat? Which means that this is 12, 28. So you can see, so from this area, so let's say you have a this distribution, almost normal distribution over here. So 28. So the area from here to here is, so there is possibility, oh sorry, so only here, only here. So this is 95% falls under here. So on 2 standard deviation or 3 standard deviation, so this is equals to 99%, so 32 and then 8. So probability to get here to here is 99%. So this is what we call as so which means that this 68% here is of my p hat will fall between 16 and 24%. And if I have two standard deviation 95%, which means that 95% of my p hat will fall between 12 to 28%. One thing I forgot to add in this previous slide. I talk about sampling variability. So which means that the sampling variability that you see that let's say the 20% the Manchester United fans talk about sampling variability is when you talk about 68%, which means that it's fall under this is 24 and this is 16, and so this is falling under. This is sampling variability. So there's the differences between sampling or sampling error. So these are the sampling differences. So this is called about sampling variability. Okay, so I hope by now you guys can understand what is sampling distribution. We have just to recap. So we have two types of sampling distribution. We talk about sampling distribution from sampling distribution for mean, and also sampling distribution for proportion. Okay, I hope you guys can already understand what's the differences or what's the application of those two.